Fractional factorial data analysis. The fractional factorial design, the whole idea or the entire goal of fractional factorial data design of experiment is to screen the variable. We're not interested in the power of the statistical power or how good this result is, things like that. That is not our interest. Our interest is, let's say in this example, assume that the process is affected by 7 variables. Now, do all these 7 variables really affecting? Do they have really statistical significance? Not all of them. Maybe 1 or 2 is basically doing everything, and rest of them are just probably there, not doing much of the work. It's very simple. However, sometimes it gets tricky to students, and I will show you why it gets tricky. So I copied this data already, and then in Minitab, and then you can go to Stat, ANOVA, you can do Generalized Linear Model, which is the most flexible one, easy to work on. So then select all the factors, and then run the analysis. Just leave everything as it is. Now, as you can see here, there is no p-value, there is no f-values, and the students say, hey, I got nothing, the Minitab is not producing results, and so on. First of all, you have only collected 8 data points. I think it's the 1/8 or 1/16 fraction of 7 variables. So you don't have, if you have 8 data points, you only have 7 degrees of freedom, and you have 7 variables. So you can't have any error degrees of freedom. There is no error degrees of freedom. There is no error in this study. There is no replication. Just once this was done for 7 variables. So we will not see any p-values or f-values. You don't need that. Remember the contrast, the estimates, the effect that we have calculated in the earlier modules, where the higher the contrast or higher the effect, there is a higher probability that that particular variable is more significant. In this case here, you can see variable C has a very high sum of its square. Variable Z has a very high sum of its square. Variable D has a little bit more. But we can definitely ignore A. We can definitely ignore F for sure. So let's rerun. So when you see that, so some variables are not really contributing to the process. Let's delete A and F. Let's see if we can get any kind of significance for the rest of the variables. So ANOVA, Generalized Linear Model, same thing. All you gotta do is basically delete that and select everything except A and F. So you're gonna select B, C, D, E, Z. I think that's all. Did you select E? Yeah, B, C, D. So we're not selecting A or F. So we'll have 5. 1, 2, 3, 4, 5. All right, hit OK. So now you see some significance of the variables. As you can see here, you can also again ignore B and E, and then probably run a full factorial analysis with interaction up to second order interaction. In this case, we can only check just one interaction, but you can see here only 2 degrees of freedom for the error term. So you have to delete some more variables if you want to see the interactions. Let's ignore B and also E, which are not significant. D is close. We're going to keep D. So let's do C, D, and G. Let's see what we find. So go to ANOVA, Generalized Linear Model, Fit Linear Model, delete all this, include now D. So we'll include C and D and then Z. These 3 variables. We have 8 data point, 3. So we probably won't be able to see all the way up to 3 level interaction, because that would be then 7 terms, but we have 6 terms in the model. We have 7 degrees of freedom, so we should be seeing the p-values. We have 1 degrees of freedom for the error. Why it's not there? Probably didn't select right. Let me go back. All right, model, It's there. All terms are there. Following terms cannot be included. Estimated remote. So something happened. It cannot check the interaction. Probably the same reason. So then you have. We can also delete that D as well and only keep C and Z. Let's see what we find. So we go to ANOVA. Just keep only C and Z with full model. So we'll only keep variable C and variable G and run full model. It's already including full model here, so that's good. Now you can see we have the full model with C and Z variable. The interaction is close, but it's still not significant. So in this entire process, just to summarize, only the variable C and Z, they are affecting the process. So from this factorial, so the next step would be, so the goal of fractional factorial design is to screen out all the unimportant variables. So now we know that variables C and G, they're the important ones. So then we can go further investigate those. If we need to collect some additional data or feed a response surface in optimizing, which we'll be talking about in the next modules. But to summarize, basically to screen out the variables. Some of the questions you get in the exam: calculate the contrast, effect, generator identifier, things like that. You have done this in earlier modules, so we're not going to be discussing that. So make sure you understand all of them too, which have been discussed in the earlier modules.